Hey everyone, Mr. Fransky here. So we're going to do another chapter review problem here for Chapter 7. This is a rate-in, rate-out type problem. There's a problem like this every year on the AP test where you have to do some rate-in and rate-out, and you have to talk about the amount of stuff that is there. So I figured that seeing this list with topics every time would be nice. So we're doing rate-in, rate-out problem here. This is 7.1. And motion is kind of a special case. We're going to do that in a different video. So let's take a look at this problem. I figured this time of year it would be appropriate to do a snowfall problem. So there is no snow on Janet's driveway when snow begins to fall at midnight. So her driveway starts clean. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by this function, 7te to the cosine t cubic feet per hour. So this is a rate. Okay, so we might want to think about our tower of functions there. So f of t is our rate. So the amount of snow, a of t, I'm going to put down there, and then the derivative of f would be like the acceleration at which the snow is falling, so how the rate is changing. Okay? And so to find out the amount, we would have to integrate, right? T is measured in hours since midnight. Okay, so 1 a.m. 1, 2 a.m. 2. I got that, okay? Janet starts removing snow at 6 a.m. So she wakes up bright and early and starts shoveling her driveway, okay? So at t equals 6. So we see that right here. The rate g of t in cubic feet per hour at which Janet removes snow from the driveway at time t hours after midnight is modeled by this function. So from 0 to 6, she's sleeping. She's not removing anything. From 6 to 7, she's removing it at a rate of 125 cubic feet per hour. So in that 1 hour, she removes 125 cubic feet of snow, okay? And then from 7 to 9, it looks like she gets a little tired. Maybe she's shoveling a little slower, removing it at a rate of 108 cubic feet per hour. So G also has its own tower of functions. G is the rate at which she's removing it. So the amount of removal would be below, and the G prime, the acceleration at which she removes it, would be above. So again, to find out how much snow she's actually removed, we would have to integrate. Okay, so this is the rate of snowfall, and this is the rate of removal. Okay, so let's see what they ask us. So first thing they ask us is how many cubic feet of snow have accumulated by 6 a.m. This is a very typical question they'll ask first. They'll kind of throw you a softball to start off. So in this case, they're only asking about the snowfall. They're not asking about removal at all. They're just seeing if you can figure out the amount of snow that has fallen given a rate. So this is a calculator okay problem, as we see right here. So we're just going to grab our graphing calculator. I think I have mine ready to go here, hopefully. Yep. And what I'm going to do is I'm going to define that function because we're probably going to be using it a fair amount. So what I'm going to do is f of t colon equals. Remember, colon equals is control. That's right next to the 9. And I'm going to do 7t and then e to a power over here next to the 1, e to the cosine. So trig cosine of t, close parentheses, hit enter. It's going to tell me it's done. Okay, so now what I'm going to do is for accumulation. So I want to know is the accumulation at 6 a.m. So that's going to be the integral from 0 to 6 of f of t dt. Right, because there's nothing on, so technically I should have the amount of snow at time t equals 0, but there's nothing on the driveway initially, right? So I don't have to worry about that. All I have to worry about is the accumulation. Actually, I shouldn't even have that there. So even if there were like 12 inches of snow on the driveway to start, they only want to know the accumulation. They don't want to know how much snow is on the driveway. They want to know the accumulation. Okay, so I'm just going to do this on my calculator. So I'm going to integrate. So menu, calculus, integral. 0 to 6, and then f of t, notice it's bold because we just defined it, dt. Control enter. 142.275. Looks like I'm not in my calculus document. I kind of want to be in it because I want to make sure I get my slope, or my enough float is the word I was looking for, not slope. So let's go to doc, file, open. Go down to the bottom here, get my BC calculus. No, don't worry about it. I'll just redefine my function. So do f of t colon equals, what was it, 7t e to the cosine t. Okay, now let's integrate that again. Menu, calculus, integral, 0 to 6, f of t dt. 142.2746. Now, they don't ask for units, so I'm not going to give them. But it looks like it'll be cubic feet. Right? That's the amount of snow that has fallen onto the driveway. Let's see how we did. 142.274 or 275. Perfect. We got 3 decimal places. Awesome. 1 point for the integral, 1 point for the answer. So this is one of those situations where you got to make sure that you write down the integral, right? You can't just give the answer. Whatever you put into your calculator, make sure you write it down. Let's see what's next. Find the rate of change of the volume of snow on the driveway at 8 a.m. Okay, so at 8 a.m. this becomes a little bit more interesting. So the rate of snowfall, so the rate the snow is falling is f of t, so f of 8. And the rate of removal, is going to be g of 8, right? These are both rates. Okay, so g of 8 we can actually find right here is 108. Okay, they tell us it's just a piecewise function here. So one of the interesting things about rates is that you can just subtract them or add them. The way I think about this is like if you have, let's say, like an airplane. I'm really bad at drawing airplanes. People call them flying baguettes usually. Okay, so here's our airplane. All right, if the airplane is flying this way and the wind, let's say, is in the same direction. So let's say the airplane's flying at 500 miles per hour. And the wind is, let's say, like 40 miles per hour. How fast is the airplane moving? 540 miles an hour. You can just add them together. Because these have the same units, I think that's kind of the best hint. If they have the same units, you can just add or subtract them. So in this case, it's going to be the rate of snowfall, f of 8, minus the rate of removal, g of 8. Right? Because the snow is falling, falling, falling. She is removing, removing, removing. And you just subtract them to find out the overall net change in the snow. Okay, so f of 8 minus g of 8. G of 8 is just 108. So it's going to be f of 8 minus 108. Let's go to our calculator. So we're going to do f of 8 minus 108. Control enter. Oh, come on. Negative 59.582. Now, this problem does not ask for it, but often they say, interpret this value somehow, or like, what does this mean for the snow volume change at this time, something like that. So the fact that this is negative, what does that mean? That means that the volume of snow is decreasing. So what does that mean Janet's doing? She's beating the rate of snowfall, right? She's shoveling faster than it's falling, which is hopefully what you want to happen, right? If the snow is falling faster than you're shoveling, that's a problem because it's going to be accumulating. It's going to like bury you, okay? So cubic feet per hour, I guess you could write, but they don't ask for units, so I probably wouldn't give them. All right, so let's see how we did. So f of 8 minus g of 8, negative 59.582, or 583 if you round. Perfect. There it is. Awesome. Okay. Let's see what's next. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway. So they're basically creating our tower for us. So g of t is the rate. H of t now they're saying is the rate that, or the amount that has been removed. Express h as a piecewise function. Okay. So we have to integrate in order to go down this tower of functions. And they want us to go from 0 to 9. Okay, so h of t is going to be, let's see. So it'll be h of 0 plus the integral from 0 to t of g of t dt. I guess we should have different letters here, huh? Let's call it, I don't know, g of x. We haven't used x. dx. Okay, so the reason I have to do it differently is because we have the t in the top here, so it can't be in the same two spots. So if we integrate from 0, that'll tell us the total amount that has been removed, and then we add to that the amount that's been removed at a given time. So h of 0, she hasn't removed any at the beginning because there hasn't been any snowfall at all. So this is 0. Okay, and then if we integrate from 0 to 6, so we integrate 0, so we're going to have to do this as a piecewise function. So we're going to have to think about this from 0 to 6, and then from 6 to 7, and then from 7 to 9. So from 0 to 6, nothing has happened. Okay, so from 0 to 6, turn my computer around here just a second. So h of t, so from 0 to 6, it's going to be h of 0 plus the integral from 0 to t of 0 dt, or dx, I guess I wrote here. Okay, and that'll be from 0 to 6. And then it'll be h of 6 plus the integral from 6 to t of 125 dx from 6 to 7. And then it'll be h of 7 plus the integral from 7 to t of 108 dx from 7 to 9. Okay, so why do we have to do 3 different things? Because the rate is changing, right? It's only good for the length of time that the rate is the same. Okay, so let's figure this out. So the integral of 0 is just 0, right? Because you can pull the 0 out, 0 times whatever's in there is just 0. So this is 0 from 0 to 6, so 0 less than or equal to t less than 6. So that means that at 6, the amount that has been removed is 0. So this is going to be 0 plus the integral from 6 to t of 125. So that's 125x from 0 to t, which is 0 plus 125 times t minus 0. So just 125t. That makes sense, right? Because if she's removing at 125 cubic feet per hour, you just multiply by the number of hours to find out the total amount that's been removed. So that means that at time t equals 7, she's removed... Oh, I did this wrong. That should be from 6 to t. So that should be t minus 6. There we go. That makes sense because... excuse me. At 6 a.m., she hasn't removed anything. So when you plug in 6 here, you have to get 0. But at 7 a.m., 7 minus 6 is 1. She's removed 125 cubic feet of snow. So h of 7, that means you plug 7 in right here. That gives you 125. So this is 125, because that's how much she's removed by 7 a.m. She's been shoveling for 1 hour at 125 cubic feet per hour. So 125 plus the integrals from 7 to t of 108. So it's going to be 108. X, I guess we're going to do it the same way I did before. Evaluated from 7 to t. So that is 125 plus 108 times t minus 7. Okay, so 0, 125 times t minus 6, and 125 plus 108 times t minus 7 are the 3 functions we're looking for here. Okay, because you're taking the amount she's removed before the new rate starts, and then you're adding to it the rate that she's removing it at. So 125 times t minus 6 between 6 and 7, and then 108 times t minus 7 for 7 to 9. Cool. Let's see how we did. Okay, so they do this whole h of 0 plus the integral, h of 6 plus the integral, h of 7 plus the integral. So they used s, I used x, doesn't really matter. So, yep, 125 plus 108 times t minus 7, 125 times t minus 6, perfect. Okay, so you get 1 point for each function. Awesome. 3 out of 3. I think there's one more. How many cubic feet of snow are on the driveway at 9 a.m.? Okay, so this is going to be the amount of snow fallen. So the amount fallen minus the amount removed. Okay. Now, tricky thing here is the amount removed is going to have to change based on the piecewise function we just made. But the amount fallen is easy. That's just integral 0 to 9 f of t dt. Okay. Then what we'll do is we'll subtract these in pieces. So the integral from 0 to 6, h of t dt. Well, it's going to be the integral from 0 to 9, right? But it's going to be split up into pieces. Okay, so this part we can just do on our calculator. So let's do that right now. So we go to our calculator here. And we do integral 0 to, I'm just going to go up and grab it, change that to a 9. Control Enter. So the amount that's fallen is 367.334. Okay. So now from 0 to 9, what we have to do here, I guess actually we have it as a piecewise function, so we can just plug 9 into our piecewise function. So let's use mine here. So we plug 9 into this last part here. H of 9 is going to follow this last piece. So it's going to be minus, hold up, nope, just h of 9. I'm doing this wrong. It'd be the integral from 0 to 9 of g of t dt, which is just equal to h of 9. This piece is just h of 9. Sorry, I didn't explain that very well. So they want to know how much has been removed from the driveway by 9 a.m., which is going to be just h of 9, the way that we defined h, because that's the amount of snow that has been removed. So h of 9 we can just do by plugging into our function. So it's going to be 367.334 minus, this was 125 plus 108 times 9 minus 7. Okay, so she's moved 125 by 7 a.m., and then she has 2 hours of shoveling at 108, so we multiply that by 2, and we should be able to figure this out. So let's go to our calculator. So we got our 367.334. Then we subtract, in parentheses, 125 plus 108 times 9 minus 7. 26.334. So she wasn't able to remove everything. There's still some snow left on her driveway. I'd probably put one more number in there, maybe 6. Okay, and that would be feet cubed. But they don't ask for units, so I'm not going to give them if I don't want to, right? So first thing they want is the integral. So they want you that you have the integral from 0 to 9 of f of t dt, and we were subtracting the h of 9 value. So you have to be able to find h of 9. You have to have the integral there, and then you get a point for the answer, 26.334 or 335. All right, so this one was a little bit closer to the wire, 15.34, but we were analyzing and kind of explaining as we went. But I believe that's the last part of the question. So I love you guys. That's why I'm here. Have a great day.